This video is going to look at number 4 from the linear programming worksheet. So we're going to read through the problem and try to decide how to pull out all the different parts. Lois makes banana bread and nut bread to sell at the market. A loaf of banana bread requires 2 cups of flour and 20 minutes to prepare. A loaf of nut bread takes 3 cups of flour and 10 minutes to prepare. She has 12 cups of flour and 80 minutes of available cooking time. She makes $2 profit per loaf of banana bread and $3 per profit per loaf of nut bread. To maximize profits, how many loaves of each type should she bake? Okay, that's our clue that's our variables. So how many loaves of each type she should bake? So our variables are banana bread loaves and nut bread loaves. Okay, next thing is to look for the constraints. The constraints are the limitations. And the limitations are that she only has 80 minutes of available cooking time and she only has 12 cups of flour altogether. So that tells us those are constraints. And so we need to have an inequality for the flour and we need to have an inequality for the time. So now let's go back and pick out the pieces that deal with the flour. Okay, so if we look at just for the flour, we have a loaf of banana bread requires 2 cups of flour, and nut bread takes 3 cups of flour, and she has a total of 12 cups of flour altogether. So we're going to put those items together in an inequality. And so that's going to be 2x plus 3y is less than or equal to 12, because 2 cups of flour for the banana bread, 3 cups of flour for the nut bread, and 12 cups altogether. Now we're going to look at how much time she has. So we're going to look specifically for anything that deals with time. So she has 20 minutes to prepare for the banana bread, and she has 10 minutes to prepare for the nut bread. So we need to put those together in an inequality, and her limitation is she only has 80 minutes altogether. So 20 minutes for the banana bread, 10 minutes for the nut bread, and she only has 80 minutes altogether. So those are our constraints. Of course, we also want to say that you can't have negative loaves of bread, so x is greater than or equal to 0 and y is greater than or equal to 0. Next thing is we are going to plug these into Desmos. So go to Desmos, plug them in. So here we are on Desmos. We have plugged in the inequalities, and we get this shape. It's kind of hard to see the way it's set up, but we have a vertex here at 0, 4, 3, 2, 4, 0, and then of course another one here at 0, 0. And our shaded area is this kind of, what is that? Just this quadrilateral in here. Okay, so this is our little shaded area. We also need to talk about, well, what was the objective? Her objective was to maximize profits. And so we need to now think about how much profit she's going to make. She's going to make $2 per banana bread and $2 per nut bread. So her maximum profit is 2x plus 2y. Now, we graphed those numbers, those inequalities, and we need to plug our vertices into this function. And so we're going to plug it in, every single one, 0, 4, 4, 0, 3, 2, and 0, 0. We're going to do our math and see what comes out. And we can see that this is going to give us the greatest profit. And so she should make 3 loaves of banana bread and 2 loaves of nut bread for a max profit of $10. And that is your final answer. You just had to do all those steps to get there.